So when we say grouping, okay, we are saying that we want to group stuff and that the order of that stuff doesn't matter. Okay, this is the fundamental reasoning behind grouping. Okay. So, and we saw that there are two ways of grouping things. So the first one is the simple grouping, where you just want to select, you just want to select or group one particular thing. And then there are multi-groups. So for a simple grouping, we saw this notation here called the binomial notation. Okay? So this is the nomenclature and kind of the way we express the grouping thing. And this brackets here with nk means that you have n elements and you have to choose k. And that the order of this k things doesn't matter. Okay? We're gonna work out the example. In the end of the day, this is a calculation because this means the number of ways you can, within n things, choose k. This is n squared minus n minus k factorial times k factorial. Okay, so it's a formula. And it means the number of ways you can choose k things amongst n when the order doesn't matter. Okay? So let's solve a simple grouping problem. And let me get myself more space. Let me get rid of this here. Okay. All right, so let's solve this one. Because of his good grades at school this year, Mitchell's parents have agreed to purchase him 4 action figures. The store has 32 distinct action figures available. In how many ways can Mitchell select 4 distinct action figures to receive? Okay? So again, when you read a problem, you have to go to your toolbox and kind of see what world you are. So when you read this question, you will say, okay, I'm not in the world of sets. I'm actually selecting something. So I might be in selection or grouping, and then you keep reading, and it says that it has to select different action figures. So if I select one, I can't select that one again. So I don't have 2 Iron Mans. I have one Iron Man, and after I selected Iron Man, that's gone. I have to select Spider-Man, and after Spider-Man, that's gone. So we have to, our brains have to set up in 2 possibilities. Selection without replacement, right? When you you select losing options, or grouping. Now, how can we differentiate? How can we tell grouping and selection without replacement apart? So think about this. Think about Mitchell's having 4 bins or 4 Ziplocs inside his backpack. He will choose amongst 32 characters, and he will put each one in his Ziploc and just wrap his backpack. So if he chooses Iron Man first, obviously that he cannot choose Iron Man again. He can make another choice. So he would choose Batman, and then after Batman he would choose Thor. And then after Thor, he could choose Spider-Man and so on. Okay, so it seems like this is a selection without replacement, meaning that Mitchell's had 32 options first. Then he was left with 31, 30, and 29. Okay, but this is not the right answer, because this problem is not a selection with replacement. Is a correction of the selection with replacement, that is grouping. Why? Because do you agree that I want to make a group of 4 characters, and if Mitchell had chosen a different order like this, let's say that first he chose Batman, then Iron Man, then Spider-Man, and then Thor, do you agree that this is the same group of stuff, right? Like I still have these 4 same characters. So I really don't mind the order in which I select. Because when we draw trees, we do the order of decision. So for example, for the first selection here, Mitchell would have chosen I, then B, then T, then S, right? You would have like a humongous tree here. But this would be the path that Mitchell chose, right? First I, first B, first T, first S. You can imagine that you're highlighting a path in this humongous tree, okay? Now, if you think about the other way, like selecting Batman, then Iron Man, then Spider-Man, then Thor, okay? Again, this is a single path of the tree, right? But if you think about it, if you are using the tree, you are counting 2 different paths. But in the end of the day, you don't care about who came first. You care about the outcome of the types. Select 4 distinct types, 4 distinct, action figures, not in the sequence, but the group, okay? So in the end of the day, whatever counting you're doing, you have to correct for the order doesn't matter, okay? So if you think about this, I could shuffle. Do you agree that I could shuffle these 4 bins, like these 4 choices around, and it would be the same thing? So in the end of the day, what we're going to do is 32 times 31 times 30 times 29, and I'm going to divide this by all the permutations I can do, but all the shuffling, okay? How many shuffling alternatives I have here? How many permutations? 4 factorial, right? So this is what grouping means, okay? So I have, if you think about this 4 bins, they can shuffle in 4 factorial ways, meaning that I have 24 ways of putting letter I, B, or character I, B, T, S, like ordering them. But I don't care. These 24 options are actually just 1. So I have to divide. I got to get rid of all this repetition. Okay? This is grouping. And so this is the reasoning behind grouping. But the formula, if you want to do it using the formula, you would do, okay, I have 32 options. I have 32 things. And I want to group this 32 things into 4, like I want to choose 4 for a particular group of this 32 things. So the nomenclature is 32 choose 4. Okay? Where the order doesn't matter. And if you work out the formula, you will have 32 factorial over 32 minus 4 factorial. So whatever is in the top comes into the numerator. Then you do the difference between the numerator and the denominator below, and finish with the denominator here. Okay, so this is the rule. You put n factorial here, you do the difference here, and then you finish with the k here. Okay, so you put in 32 in the numerator, you're doing the difference between them here, and you're finishing with the 4 here. Okay? So in the end of the day, if you work this out, this is 32 factorial over 28 factorial over 4 factorial. Okay? And this, using the formula, is exactly the same thing as this, using the reasoning. Why? Do you remember that last lecture we worked out this division here of factorial by factorial? Meaning that if you want to truncate a factorial, you divide by the next term, like this. Look, 32 times 31 times 30 times 29 times 28 up until 1, right? This here is 28 factorial. But I want to truncate in 29, so I have to get rid of that factorial. So this will cut this, and we are left with the very same result that we did before. Okay? Good? Good? Questions about grouping? This is the time to ask. Yeah.
What's the point of the rest of the formula if it just goes back to the same thing in the beginning?
Like you can do grouping by reasoning that the order doesn't matter. You can. It's just that, and we will see in the last exercise that this kind of the direct application of the binomial notation, this notation eases a little bit further steps. But it's the same. You can do it like thinking about that grouping is a particular case of selection without replacement where order doesn't matter, and just divide by all the permutations that you can have. So all the shuffling of the things you selected doesn't matter, so just divide by the permutation. But you can also apply the formula. It will lead you to the same answer. Okay? But applying the formula is it's very it is actually imperative that you know the formula, because sometimes in the multiple choices that you have, you will have like the binomial notation there, and you will have to understand what the binomial notation is. Okay? So again, the binomial notation is within n elements, within 32 elements, I have to choose 4 with no order mattering. Okay? Okay. So this is the first type of grouping, right? It's the first type of grouping, which is a simple group. I'm taking things and I'm just selecting a simple group. Okay? There's another type of grouping that is what we call a multi-grouping, or when you have more than one group. Okay, so let's work this now. So for the multi-grouping thing, okay, we have for the multi-grouping thing, we use a notation called the multinomial notation. Okay, so it's if you take n things and you want to choose k1 things to form one group, k2 things to form another group, k3 things, and so on. Okay? So this is the multinomial notation, and it means that for example, this notation here means that you have 3 groups, and each group has k1 elements, k2 elements, and k3 elements. Okay? And it's quite the same thing. The formula changes a little bit, but it's actually even easier to remember. It's just the numerator, the top part here, The upper part of the brackets is the numerator, and everything else comes into the denominator with a factorial. Okay? So again, if you think about reasoning a problem, you can by dividing by the permutations. But now imagine that you're doing several groupings with several different elements, and then it might be that at some point you forget about compensating for the permutations, and that's why the notation is useful, right? So it gives you the calculations directly without going through the steps. So let's work out this example. This example says like this. An 11-person graphic design committee is to have 1 project coordinator, 2 senior graphic designers, 1 photo researcher, 2 layout artists, and 5 junior graphic designers. Okay, so you have 11 person to choose, right? And so you're building a committee with each with different assignments, but you're kind of you're choosing from 60 employees, right? So I have 60 employees in my company, and I'm going to pick 11. Actually, one of them will be to project coordinator, 2 to senior graphic, and so on. And there's a condition here saying that any of the 60 employees can be assigned to any position. So, meaning that you're free to choose whoever you want to what position you want. Okay, so there's no constraints actually. No constraints. Okay, so when you read the problem, you should kind of position yourself and try to figure out what tools or what we're talking about. Breaking the words into tasks and finding the right tools to solve the problem. Okay? So when we're doing this, you could think about, okay, it's a selection for sure. Because I have to select, for example, if I select Louisa to be a project coordinator or a senior graphic designer, she's selected and I cannot select her again, okay? But always when you say, okay, selection without replacement, think about this. It could be grouping, right? Because it might be that the order doesn't matter. So here's the thing. Let's say that I'm gonna pick 2 persons to be senior graphic designers. If I say, okay, I don't know, Andrew, right? Yeah. Andrew is 1, and I forgot your name, sorry. Nicole. And Nicole, they're going to be my 2 senior graphic designers, okay? Does it matter if I said Nicole and then Andrew? The outcome, the group is the same. I don't care if I selected Nicole first and then Andrew, or Andrew and then Nicole. Okay? So this is not just a selection without replacement. This is a particular case of grouping. Okay? And in the end of the day, how many groups am I selecting only one group? No, I'm selecting coordinator, I'm selecting people to the group of coordinators, to the group of senior graphic designers, to photo researchers, to layout artists, and to junior graphic designers. Okay? So in the end of the day, I have this 6, so I am in grouping, and I already know that this is a multi-group problem, and I will use multinomial notation. So I have 60 people in a bucket or in a room, and I have 4 different groups or bins inside the room, or I don't know, locations or tables or whatever. And actually I have 5 groups, right? The first group is the group project coordinator. The second one is graphic designer, photo researcher, layout artist, and junior graphic designer. Okay? So it's fine. I'm just going to use my multinomial notation. So I'm going to take 60 people, and I'm going to choose one to my first group, which is project coordinator. Then I'm going to choose 2 people for my second group, which is graphic designer. 1 again to photo researcher, then 2 to layout artists, and finally 5 as junior researchers. Okay? Now, is this the answer? I mean, obviously it's not, because I wouldn't be asking it. But does anyone kind of see the problem here? So look at there's a property of multinomial notation that says this: K1 plus K2 plus K3 must be equal to N, right? So let's see here. I'm taking 1 people, 2, 3, 4, 5, 6, 11, right? I'm taking 11 people to my committee. Is this equal to 60? No. Why? What am I missing here? Actually, is one property of grouping is that, let me put this 60 in the middle so it's easier to see. So what's missing here is that when you group things, you are obviously grouping. If you group things in one group, you're obviously selecting another group. So for example, if I have 5 people, or 5, and I say I want to select 2. To this group, so this is the group A. Do you agree that automatically I have selected a group of other people, right? So in the end of the day, what is missing here is the group of all the other employees that I have not picked, which is the group of the rest of the employees. So how many people do I have in this rest group? 49, right? It's what's missing to sum up to 60, right? So every time you are doing a multinomial, multi-group kind of exercise, check if the sum of the bottom part is actually matching your universe or whatever, the number of things you have, okay? If it is not matching, you might be forgetting the natural selection of one of the groups, right? That is, when you select, you're automatically selecting something else. So don't forget about this, okay? Okay, cool. Just bringing this up, there is a special property of the of the binomial notation that is. So the special property for multinomial notation is this: n, k1, k2, k3, whatever k's you have here, right? Kp, I don't know. So you will have that the bottom part has to match, okay, the upper part, okay? And for binomial notations, you don't have a sum in the bottom part, right? You don't have, because you're just grouping it once. But it's natural that, for example, if you group 5 things into, if you choose 2 in a particular group, it's the number of ways that I can do this. Remember, this bracket thing, this notation means the number of ways you can, within 5 people, choose 2 is the same as the number of ways I can choose 3, right? Exactly because of this image here. So the number of ways I can choose 2 is exactly the same the number of ways I can choose 3. Right? Whenever I choose 2 people, I'm automatically ditching the other 3 to the other group. Okay? So this is also another good property to know, because it might be that your answer is not, in the test, is not 5 choose 2, but is actually 5 choose 3. So you have to know that they're the same. Okay? Questions about groups, multi-grouping. Good? All right. All right. So now we're going to do the last exercise, which is the most difficult one from the recap, but it's very good to show like a style of problem where you have to know what you're doing and differentiating selections with groupings and so on, and permutations. Okay. So here's the thing. This problem here is a multi-grouping problem, but there's an aspect to this problem, that is, you have groups that are indistinguishable. Okay? So, we saw that, for example, the indistinguishable letters, raccoon, no, it wasn't raccoon. Well, adoption, for example, we did an exercise with the word adoption. You have 2 O's. If things repeat, you can't tell them apart. You have to correct the counting. You take like how many times it repeats. For example, 2 O's, you divide by 2 factorial. If you had 3 O's, you would be dividing by 3 factorial, and so on. The same rule applies to group. If you have indistinguishable groups, you have to correct the indistinguishability, or the number of times it repeats. So if you have a multinomial thing like this, let's say 3, let's say 3 groups, but 2 of them are indistinguishable. I don't know. There are P groups that are indistinguishable. You will divide by P factorial. Okay? Which is the same thing as multiplying by 1 and then divided by P. Okay? I like to leave it this way because I know that I'm grouping and then correcting. Okay? For indistinguishable groups. Okay, so let's read it. Let's read the problem. It says like this. In a study exploring group dynamics and task performance, 20 participants are randomly divided into 5 equally sized therapy groups. Okay, so there's some task, and then you have 20 people there, and you're dividing it into 5 equally sized therapy groups. Okay? Each group will engage in a mindfulness activity aimed to promoting mental well-being. So each group will kind of meditate. Okay, cool. At the end of the study, so after people meditated and everything, the participants in one selected group will have the opportunity to receive one of 7 different incentives. Okay, so stop there. I have 5 groups. They're meditating. And there will be a group. There's a chosen group, right? It's the chosen. They are the winners or whatever. And and they will receive a reward. Okay, so this is the storytelling. Okay, they will this people from this chosen group will receive a reward. There are 7 different rewards or incentives, and each participant from that chosen group can choose one. Okay, so let's stop. I know what I'm talking about now because I broke the problem into tasks. First of all, I have to take this 20 people and divide them into groups, right? Into 5 different groups. One of these groups are the star group. These people from the star group will have to choose 7 rewards. Will have to choose among 7 rewards. They will have to choose these rewards. And the question is, how many different ways can the participants be divided into groups, and how many different ways can the participant choose their rewards? Okay, so let's do it from task to task. First of all, I have a bucket of 20 people, or a room of 20 people, and I want to put them into 5 different groups. 1, 2, 3, 4, and 5. Okay? I know that within these 5 groups, there is the chosen one, or the star group, right? So I'm telling you this one is the chosen one. Okay? Well, if I'm dividing 20 people into 5 groups, how many people will I have in each group? Four, right? So 20 divided by 5, 20 things divided in 5 buckets. That's 4 for each bucket, right? So I have 4 people here, 4 people here, 4 people here, 4 people here, 4 people here. Awesome, nice, very good. So I know what I'm doing. It's a multi-grouping. Let's multi-group. So the first task is a multi-grouping. I'm going to take 20, and then I'm going to group it into a first group of 4, then a second group of 4, then a third group of 4, then a fourth group of 4, and a fifth group of 4. Okay? It's too good to be true. This is not the answer for the first task. Why? What is happening here that is different from the other question where you had the project manager and everything, like you had the groups? What is the difference? Well, it's adding up, right? So 4 plus 4, 8, plus 4, 12, plus 4, 16, plus 4, 20. So it's adding up. But, yeah. Exactly. So what is happening here is that I'm having groups that are indistinguishable. Okay? If you take a look at the previous exercise, this exercise here, here, each group was labeled. Or think about this, you're putting you're grouping people and putting them on a specific table, right? Or sitting them somewhere, or labeling them, or putting a tag. Here, this group is distinguishable, right? Because I know that 4 of that people will be on this chosen group. But what about the rest? Is there any way I can just, is there a label? Like saying, oh, you're in group B, C, D, or E. No, there's no label, okay? And the number of people is the same. If I had one group with 3 and the other one with 5, the number itself of members can distinguish, okay? But when I have the like number of people, the same number of people with no label, there you can tell them apart. And then you have your brain has to be here, and I mean your brain has to go to the multinomial part of the course and say, should I correct for indistinguishability? Yes. How can I correct? I will divide or multiply by 1 over the number of repetitions of that group, right? The numbers of the number of repetitions. So this group repeats not repeats, but you can tell them apart 1, 2, 3, 4 times. So this is the p factorial here. It's 1 over 4 factorial. Okay? And the reason why we do this correction, it's in the videos. If you can go back, because I won't go through it all again. But if you think about it, and I say, okay, I have Louisa and Daniel, okay? And I say, I have Louisa, Daniel, Amanda, and Sarah, 4 people. And I say, break into groups of 2s. I'm not saying break in A and B, right? I'm just saying break in 2. So if I change them, the position of the group in the room, for example, I don't know. They're still the same. They're still the same, okay? So I have to correct. But I suggest you to go back and see why. And I in the video, I kind of do some reasonings there so that you can understand. Okay, so this is the first part of the exercise where you grouped and you corrected, okay? All right. Now, let's continue. At the end of the study, so they meditated and everyone, and the ones that went to the chosen the group, right? They will receive a award or a reward. There are 7 different types of rewards. And the rewards are personalized coaching sessions. I don't know. There are 7 different types of things. And they say like this. These people from this group. So I forget about the other test. Now I'm in the world of the first group. I kind of get inside this group where I have 4 people, and they have to choose within the 7 things. But it says like this: there 2 participants cannot choose the same incentive. Right? So you are in this world of choosing, of selecting, and you can't select the same reward. So meaning that if you have 7 rewards, R1, R2, R3, R4, R5, R6, and R7, if you select one of them, you can select it again, right? So this brings us to where? Selection with or without replacement? Without replacement, right? Meaning that let's say that here is Louisa, Nicole, Andrew, and Sarah. We are the chosen ones. And we have to select, I want R1. I start and I say, I want R1. And then Nicole says, I wanted R1, but I can't get it anymore. I'll choose R3, right? So we are losing options at each decision. So the second part is this. I have person 1, person 2. Think about a tree where you have 4 layers of decision. The first person is coming in, and the first person has how many options? 7, right? The second person has how many options? 6, 5, and 4. Okay? Now, because this is a subsequent task, like first I'm going to group, then this 4 people will choose the awards. all these possibilities here, because I could have gotten different people here. There are several options. They're all inside this big formula, but every single of these options will branch into the different decisions that these 4 people can make. Okay? So if you go to, this was the question from quiz 1 last year, and if you take a look at the answer is posed like this. It's 20, 4, 4, 4, 4, 4. Correct for the indistinguishability, and then select without replacement. The answer was this. Again, the truncation thing, right? So you when you see this kind of thing, you have to imagine, oh, this 3 here is stopping my factorial at 4. So I'm kind of truncating, right? So if you think about it, 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. This is 3 factorial. If I divide by 3 factorial, this will kind of do that. And I truncate my selection. Okay? Questions? Last year, I wouldn't say that it was too many students, but some of them gave the answer like this. Let me show you here. It gave the answer like, take 20, divide into 5 groups of 4, okay? Then correct for the ones that are not distinguishable, and then that 4 people, the first people here, second, third, and fourth of the chosen group will have to choose within 7 rewards. They have to choose, right? So some students said, "Oh, this is 7, pick 4. 7, choose 4." Okay? And this is the trap of. This is actually where you have to know that this is different from the other answer. Okay? And I'm gonna go through with you so there's no doubts here. So the correct answer is this, right? This is the correct answer. And this is the wrong answer. So why? What happens here? Well, if you think about so Louisa, Nicole, Andrew, and who else I know? Louisa, Nicole, Andrew, and Daniel. They are in this group, like this chosen group, right? I'm asking how many ways they can select, okay? I am not asking how many ways they can select the types, the different types. So if you think about, if I select R3, then Nicole R2, then Andrew R1, and Daniel R7, this is one way of selecting it. The other way of selecting would be R2, R4, R5, and R7, okay? I am not asking, so all of these are different ways I'm selecting, I'm distributing the rewards. Okay, they're different. I'm not asking, oh, from this 7, select 4 that will be given. It's not that. The order, and in this case, the order matters. It is a path that, for me it matters because it's a way they can select. I'm not interested in only the outcomes, right? Okay? So that's this answer. The first part is right, but the second one is not. And this one is completely right because here you are considering these different choices for me, right? So for Louisa, if you think about sit in my head, like I can choose within R1, I can choose R1, R2, R3, or 4. I have 7 choices, right? The other one will have 6 choices as well. I'm not grouping them into the type of rewards, right, that we are doing, okay? This would be take 4 to give them, but it's not showing you the way I could give them, okay? It's subtle, but it's different. And it's very much, this is very different. This here is 7. If you use the formula, this is 7 factorial over the difference, 3 factorial times the last term. So you would be dividing by 20, by 24 here, and here you're not. Okay? And that's all. We're done. This is the most difficult exercise, I would say, because it has several parts. But it's a good one to know that you have to break the problem and you have to know what you're using as a tool, and try to differentiate what is grouping, what is what the order, if the order matters, right? Okay. And if you're super you don't seem to kind of get if it's grouping or selection, you can downsize, do a mock example on the side of your test, and say well, imagine that there are 2 people, Louisa and Andrew. They're actually choosing between 3 rewards. So downsize it, right? Is this the same thing as this? For the selection, if Louisa chooses R1 and Andrew chooses R2, is the same as Louisa choosing R2 and Andrew choosing R1? It's different, right? Because Louisa will get different things. So it's not the group R1, R2, the type of the reward that matters, right? It's the order matters for the person that's choosing. The order matters, okay? So always try to downsize if you're still not getting it. Good. Okay, this is the recap. No, don't leave. I'm just going to start introducing probability. So now we're starting a new content. It's not for midterm 1, but I kind of have to start right now. So otherwise I will be lagging behind. So let me go and let's start talking about probability. Let's start talking about probability. Look at this. It's just an introduction. It's really fast, okay? I promise. Okay. Let me close here. And here you go. Why can't I? Oh, here we go. Okay. Okay, so we're going to start talking about probability. Okay? Why on earth are we counting everything? Like, why am I curious about how many ways the winning people chose 7 incentives? Why are we doing this? Like, most of you are going to psychology. Why on earth are we doing this? Yeah.
This is going to be on the exam, right?
No.
Okay.
All right, so we're done with midterm 1, okay? Oh, I want to suggest one thing. I said this in the other section. Don't leave like, oh, I can study this in 3 days before the test. I mean, some people tend to do that and go over the concepts and think, oh, I will know how to do it. Like, in math, it's very unlikely that this will work. So my suggestion is you have 8 days for the test, 9 days. Start right away trying to solve problems from the past midterms. Go read, try to do it first, and then go to the solution, see whatever you didn't think about, and work yourself there so that you can get this practice. Otherwise, it will be unlikely that you will be successful in midterm 1, okay? So it's just a suggestion, because I had some other students come, oh, I have statistics, whatever. I'm going to leave like 3 days to study for Math 1228. And I was, no, you're not going to do this, right? So start right now, okay?